So when we do our lab, we're going to be mixing baking soda, and we're going to be reacting it with the sugar like you guys saw in the video. Okay, and then you're going to make these 4 compounds. Okay, now, if you guys remember, when the fire snake was being made, you guys remember how there was bubbling, right? So the bubbling are the air molecules that are being formed. And so these 2 right here, if you guys notice, these are the gases, right? So these are the bubbles that you guys saw. Okay, so the bubbling that you saw were these gases being made. Now, the reason why that the fire snake, let's start with the color. The reason why it's black is because of this carbon that is formed. So this produces the black color of the fire snake. Okay. So it's black because it makes this carbon. Okay. It's basically the same chemical as charcoal. If you guys have ever seen charcoal or used it in a barbecue, it's basically making charcoal, and that's what makes that black color. Okay, now the reason why the CO2 and the H2O gas doesn't just fly away into the atmosphere is because it gets trapped in this solid compound that's formed. So this is going to be the actual the snake that is being made. So the chemical that makes up most of that snake is this right here. Okay. And the reason why it grows is because the gas bubbles get trapped in there, and that's why it makes that's why it's able to grow out of the container. Okay. So this is pretty much the lab that we're going to be doing. And so we're going to run the experiment, obviously, and then after that we're going to calculate some of the things that are involved. Okay. So let's start with part A, is energy absorbed or released? For that, we got to look at the delta H, and if you guys notice, it's a negative number. So when this reaction runs, energy is going to be released. Okay, it's exothermic, and we can kind of easily see that because if you remember, it was burning, and when something is burning, typically that means energy is coming out of the reaction. Okay, so energy is being released in the reaction. All right, so the first thing that we are going to be calculating is going to be how much energy is actually absorbed or released. Okay. Now, the calculation that we do on Monday is going to be a little bit different. I'm not going to give you 77 grams of baking soda. That's a lot of baking soda. But for today, for our lecture, we're just going to work with the 77 number. So for our energy calculation, we're going to write down our starting number, 77 grams. And again, when we do the lab, you're not going to do 77 grams. You're going to get a lot less than that. Okay, and we're going to set up 2 fractions. So to calculate energy, we're going to do stoichiometry, but we're going to need 2 fractions. Okay, so for this first fraction, you guys see how we have grams and moles, right? And so we got to go to our periodic table. So let's take out our periodic table, and I'm going to give you guys about a minute or so. See if you guys can find the molar mass of the baking soda, NaHCO3, and see if you guys can plug it into this first fraction on your own. Again, you're going to go to the periodic table, find the molar mass of baking soda, and we're going to plug it in right here. So take about a minute or so to do that, and then we'll go over it together. All right, guys, so let's take a look at the periodic table for NaHCO3. So we got to add up the elements that make up the baking soda. So if you take a look at Na, you're going to see that the number is 22.99. You're going to add that with the H, which is 1.01. You got a carbon, which is 12.01. And then you have 3 oxygen, so you would have to add oxygen 3 times. So it's the number on the bottom, 16. Okay, so we got that right there. So we're just going to plug that into our calculator. So we got 22.99 plus 1.01 plus 12.01, and then 16, 3 times is 48, so that's going to give you 84.01. Everybody good with how we got that number for molar mass? Okay, so we're going to plug that into our fraction. Now, if you remember, the number you get from the periodic table always goes next to grams. So grams is on the bottom, so we're going to put that on the bottom of our fraction, 84.01. Okay, and then the number on top of the first fraction is always 1. So if you didn't make a note of that, you can put that. The reason why is because The molar mass, by definition, is the weight or the mass of 1 mole. So that's why we put the 1 next to moles. It's 84 grams in 1 mole of baking soda. Okay, so that's where we get this first fraction. The second fraction, we get the numbers from the balanced equation. So if we look at the balanced equation, the number in front of the baking soda is 2. So we put a 2 on the bottom right here. And the kilojoules is negative 523.24. That's just the delta H value right here. So that's where we get the numbers for the second fraction. All right, from there, it's pretty simple. We just go left to right, multiply the numbers on top, divide the numbers on bottom. So 77 divided by 84.01 times negative 523.24 and divided by 2. And so for our final answer, we should get about negative 239.79. So negative 239.79. And make sure to always label your number. It's going to be kilojoules. Okay, so if you ran that fire snake reaction that we're going to run on Monday, and you use 77 grams of baking soda, this is how much energy would come out of that reaction. Okay, that's what we're calculating. How much energy comes out from that reaction. All right, so that's the first thing that we are calculating. The second thing that we are calculating is how much of the chemicals we're making. So when we actually do our lab for the post-lab, you're actually going to calculate how much of everything that was made. But for today, for the sake of time, we're just going to figure out how much carbon dioxide was made. So part of the bubbling. So when we looked at the video of the fire snake and we saw the bubbles, some of the bubbles being made was carbon dioxide. So we're going to figure out how much carbon dioxide is made. So for this one right here, we're looking for grams. So we're going to do the regular stoichiometry. So we're going to take our starting number. It's the same starting number, 77 grams of NaHCO3. And this time, we're going to set up 3 fractions. So we're going to set up 3. Okay, and I'll give you guys a minute or so to copy down, filling in the fractions. So if you take a look at the first fraction, it's going to be moles over grams for our starting chemical, NaHCO3. But if you guys notice, that's the exact same fraction as this one right here, right? So we actually did the work for the first fraction in the previous problem. So we can just kind of copy it down for part C. You got 1 mole of NaHCO3 and 84.01 grams of NaHCO3. Okay, so for that one, you don't even need to do any work because we already did it. This is the molar mass of your starting chemical. So this is a molar mass of your start. For the second fraction, we're going to get the numbers from the balanced equation. So we're going to look for these chemicals in the balanced equation. So let's take a look at it. If you look at CO2, the number in front of CO2, if there's a blank, it means that it's the number 1. So we're going to put a 1 right here. Okay, so if there's no number in front of a chemical, it means it's the number 1. For our baking soda, it's still 2, so we put a 2 on the bottom. And then for the last fraction, we're going to get the numbers for this from the molar mass of our ending chemical. Okay, so I'm going to give you guys about a minute or so. I want you guys to go to the periodic table again, see if you guys can find the molar mass of CO2. But just be careful where you put the molar mass. Again, just be very mindful of where G and moles are on the fraction. So take a look at that. See if you guys can plug it in. After that, you can punch it all in your calculator and you'll get your final answer. And that'll tell you how many grams of CO2 we're making in this reaction. All right, guys. So I'm not going to go to the periodic table, but if you want to reference it, you can. But C is 12.01. O is 16, and there's 2 of them, so if you add that all together, that's going to give you 44.01. Okay, and again, we put that next to G. And then, if you guys remember, periodic table, if you get the numbers from the periodic table, the moles is always 1. So this is what your last fraction will look like. Okay. All right, from there, we just go left to right again, multiply the top, divide the bottom, so we write 77. Divided by 84.01, divided by 2, times 44.01. And so our final answer is going to be about 20.1617. And so that is going to be how many grams of CO2 are being made. So when we saw the video of the fire snake with the bubbles, some of the bubbles was CO2, and the amount of CO2 that was made is 20.17 grams. Okay, so that's what our math is telling us. Part B is just telling us how much energy is being produced. Part C is telling us how much CO2 is going to be made. And when we do our lab, for the post lab, you're going to find CO2, but you're also going to find all the different components that are being made in the experiment. Okay?